So this video is on the scatter plot portion of the Unit 4 D-Day. So I have up the worksheet and I have up also my Desmos. And I would recommend right here going to sign up. Okay, and you're going to sign up using your Google. Okay. And you see now I'm signed in. And then over here, I'm going to put a title. I'm going to call this Unit 4 D-Day Scatterplot. And then to come up with your table right here, this plus sign, we're going to come here and we're going to click on table. And now we're going to enter in the values. Okay, so these are the values here, study time hours that I'm going to be putting in. So 1.4, 5.8, 4.5, 2.6, 3.5, 0.5, 3.0, 4.0, 2.2, and 5.1. And then I'm going to come over here and do my Y's. Okay, so here's the Y's I'm going to be doing. So 62, 87, 85, 70, 72, 46, 74, 81, 68, 90. And I'm just going to double check. So over here, I'm checking to make sure I have a 1.462, 5.887, 4.585, 2.670, 3.572, 0.546, 3.074, 4.081, 2.268, and 5.190. I would recommend checking all of these just in case you type something in wrong. You want to make sure that you have the right data. Now you'll notice that I do not see my values here. Now I'm going to make this a bigger graph here. And again, I'm still not seeing it. And the reason is because I need to zoom in or out. Now the problem is my X's, basically I'm going from 0.5, which is my lowest, smallest, to 5.8. That's the most my X's move. My Y's though, 46 to, let's see, 90, okay? So the problem with this is if I just keep zooming in, you see that it keeps both X and Y axes the same scale. So you can see up here, I'm seeing my graph, but it's really bunched up because from here, this is 0 to 10, just right here. And so that's my whole entire graph is within this one little box, basically going up. So I'm going to come to my wrench, okay, and I'm going to actually hit projector mode just to make it a little darker for us on the video. I'm going to come to x-axis. First thing I'm going to do is I'm going to put my title, okay, and so let me just go back here. So this was study time in hours and then score. So I'm going to click here and I'm going to do study time hours. And then from here, I'm going to go from 0 to, let's say, 6. Okay, or 0 to 10 if you want, but 5.8 was kind of my most. Now my Y should be score, so I'm going to come here and I'm going to put score. And then my score, the lowest was 46 and the most was 90. So let's say for a graph that's a scatter plot graph, a statistical graph, you don't have to necessarily, if your graph is kind of up in a different range, like where maybe all the points are in this little area, you can kind of skip over to there. So let's say I'm going to go from 40 to, let's say, 100. Okay. And then I'm going to close that wrench. And now I can see my graph better. So I'm just going to open this up. So there's my graph, okay, and I can kind of zoom in if I want. And now you see this is going, this is 1, 2, 3, 4 going like this, where this is going 20, 40, 60. So my X and my Y, as I zoom in and out, They are not zooming the same amount, which is good because my X's are relatively small. Okay, the next thing I'm going to do is I'm going to come here to the line right after my table, click on here, and I'm going to type in Y1, and next to the number 1 is a tilde or a similar symbol in math. You're going to hit Shift and that. And this is what you're always going to do when you want to get a regression. You want to get a line of best fit, a parabola of best fit, an exponential of best fit, any type of graph of best fit. And then mx1 plus b. Now this is really y equal mx plus b, but I'm using the y1, x1s from my table. See, these are x1s and these are y1s. And then it drew the line of best fit for me. And here you can see our equation, 7.67 and 48 point, let's say 48. The 6 is going to push us up to a 49. Okay. So I am going to shrink this so that I can be looking here also. I am going to want to insert this graph and my line of best fit. So I'm going to come up here to the share. I'm going to go to export image. You can choose whatever you want. I think I'm going to do a little bit of a medium. Thick might be a little too thick. And I'm going to hit download. Okay. And now I can come over here to my my worksheet on Cami. I'm going to come here to add media. Okay. Add media. I'm going to go to the folder from my computer, and then I'm going to grab it. And here's my graph. And you see I have the X labeled and the Y labeled. And then here's my scatter plot along with my line of best fit. Okay, so now the next thing I'm going to do is I am going to describe my scatter plot. Okay, describe my scatter plot. So let me kind of zoom in here. Now, for the scatter plot, you can see that's an increasing line. These points are relatively close to this, so I would say that this is strong. You can always look at your R, this R right here. Okay, let me just circle it. So this R right here is your correlation coefficient. It is always going to be from -1 to 1. And negative if it's decreasing, positive if it's increasing. If it is exactly 1, every point, let's see if I can make these a little bigger. So every single point, every point would be perfectly on it. And that's not the case. Okay, that is not the case. But they are close, and that's why this is relatively close to 1. Okay, so again, I'm going to be using this R right here to kind of help me. This is my slope. This is my y-intercept. Okay, so for describe the scatter plot, I am going to be looking at my, let me just get my mouse back. I am going to be looking at my sentence frames. Okay. And the one I'm going to be looking at right now, let me get that up. Okay, so here is our described scatter plot. Okay. And so, let me get this going here. Okay, so I am going to write, there is a, and then I decide strong or weak. I'm going to say strong. Positive or negative, this is increasing line, so it's positive. Linear relationship between, and then my X variable is the number of hours studying, and my Y variable is score. So there's a strong positive linear relationship between the number of hours studying and the score on a test. Okay, now the next thing I'm going to do is what is our line of best fit? Okay, so I'm going to come back here. And again, I am going to be looking at my M and my B to help with my equation. Okay, so again, these are the ones. So I'm going to write y equal, give me two numbers after the decimal, so 7.67x plus 48. The 48 is going to push up to a 49 because of that 6. And let me just fill this. Okay, so that is my line of best fit. And again, just to make sure everyone understands, because we're going to have to look at this here in a second, this is my slope. And this is my y-intercept. Okay. So the next thing I'm going to do is I'm going to interpret the slope, again, using my sentence frames. So the sentence frame I'm going to look at is right here. Okay. So let me get my table. Okay. So I'm just going to kind of put here what my M is just so I remember. My M is equal to 7.67. Okay, 7.67. 7.67. Okay, that's not my sentence frame. That is just so I remember what my slope is. So now I'm going to do my sentence frame. And so interpret the slope. So on average, as the study time increases by 1 hour, got to put the units in, the score on a test, and again, you have to pay attention to your line, whether it's increasing or decreasing. This is increasing. Okay. Increases by my slope, 7.67, let's say percent. I think this is probably in percent or points. Okay, so now the next thing we're going to do is interpret the y-intercept. Okay, and again, you can find your y-intercept right here. This is your y-intercept. So I am going to just put b equal 48.49. That way I remember what it is. And then I'm going to be doing this sentence from right here. Okay, so when the study time is 0 hours, the score on the test is about 48.49%. Okay, we're thinking about these as percent, or points if we were thinking about these as points. The next thing we're going to do is we're going to predict how many, if we sit it for 3 hours, what the score will be. So we're going to be using our line of best fit. Okay, so let me just make this a little bigger. I'm going to be using this line right here. Okay. And let me just get fill. Okay, so that's the line I'm going to be using. So I'm going to go y equals 7.67x plus 48.49. Okay, that's the equation. My 3 hours is my x. So I'm going to go y equals 7.67 times 3 plus 48.49. And I want to see what I get. So I am going to just copy this. And I'm going to go to my Desmos. I'm going to go to a line below, and I'm going to paste that. And I see I get 71.5. So 71.5, let's say, percent, okay, is the score that we would get if we studied for 3 hours. That's our prediction. Now this one says calculate the correlation coefficient. So the correlation coefficient is this R right here. Let me circle it. Okay, this is our correlation coefficient. So we're going to say, let me get my, we're going to be using this value here. Let me just get fill. Okay, so we're going to say R is equal to 0.9601. Okay, whoops, not T, sorry, R. That is our correlation coefficient. The next thing we're going to do is we're going to interpret that correlation. So interpret that correlation. We're going to come here, and here's our sentence frame. Okay, so let me just get this set up. Okay, and we're going to be right here. So I'm going to say since, I'm going to get this a little darker, it's pretty light. Okay, so we're going to say since, can't type, since R equal 0.9601, okay, 9601 is, and then we're going to say either close to or far from. So this is going to be close to, and then we're going to either say it's close to or far from 1 or -1. Since this was my R is positive, I say 1. There is a strong positive linear relationship between the number of hours studying and the test score. So the next thing we're going to do, how many hours would a person need to study in order to get a score of 95? So we're going to take this equation up here. Okay, that's the equation we're going to take. Just going to copy that. Okay, and let me paste that. Oops, I just wanted this one, sorry, text box. Okay, so we're going to take that equation. And this time, this 95 is not our X. X is how many hours. This 95 is our score, so that's going to be our Y. So that 95 is going to be our Y. So we're going to go 95 equals 7.67X plus 48.49. And then we're going to subtract 48.49 from both sides. I'm just going to space this a little bit more. Okay, so again, I'm going to be subtracting this from both sides. So over here, well, let me just get this. So minus 48.98. And I'm going to do it here too. Minus 48.98. And so this, I'm subtracting here, and I'm subtracting here. And then I'm going to do that math. Okay, so I'm going to do 95 minus 48.98. Let me get my Desmos. So 95 minus 48.49 is 46.51. So 46.51 is equal to 7.67x. Then we're going to divide both sides by 7.67 here. I'm just going to copy this. And I'm actually going to do it with equation. I'm going to come up here to the f of x. That way I can do fractions easier. Okay. So I'm going to take 46.51 divided by, oops, I guess it won't let me do that. Here, I'll just put it in here. 7.67. Let me get rid of that. Wouldn't let me paste. Okay. Let me make sure I'm in my equation. Equals 7.67 divided by 7.67x divided by 7.67. That's supposed to be an x here. And when I do that math, I'm going to come over here. I'm going to take 46.51. So 46.51 divided by 7.67. And I get 6.063, actually 6.06. So that is our x. So if we have a 95, we probably studied about 6 hours, okay? So that is the video on the Scatterplot portion of the D-Day. The rest of it is review, with the exception of this right here is you have to match the Scatterplot with the R. Okay, so this one you're going to match to one, either A through D, and same with these. This is solving equation review. Multiplying using the box area model, laws of exponents, substituting in 2, this is f of 2, this is function notation, putting 2 in for x and solving, graphing this. Now if you want, you can graph this on a separate sheet of paper and put it in. I don't want you to be graphing on Desmos, I want you to graph it. And again, area model. This is, again, an area model, and you might want to rewrite this. This is really the quantity x plus 2 times the quantity x plus 2, and then you can do an area model. That's what that really needs, okay? And here we're solving for x. Here we're looking at the scatter plot and answering these questions. Here we're talking about correlation and causation. I have I had a little video I played for you guys the other day on that says ice cream kill is killing, or ice cream kills. More review, again, area model, solving for y, fraction besting, okay, again, more graphing, and then more laws of exponents. Hopefully you find that scatter part of this easier to understand. We want to be prepared for our test on block day.